I welcome you all for this GATE coaching class. I am Ms.G SWATHY, Assistant Professor, Department of Mathematics, SA Engineering College. In this session, we are going to see about the concepts of numerical methods. Before going to the concepts of numerical methods, we need to know what is algebraic equation and transcendental equation. Algebraic equation. The equation of the form f of x equal to 0 are called algebraic equation. It is purely polynomial in x. The polynomial equation f of x equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. an minus 1 x plus an equal to 0. Examples of algebraic equation are 2x cube minus 3x square minus x plus 5 equal to 0. Another example is x power 4 minus x plus minus 10 equal to 0 is a polynomial equation of degree 4. Next is transcendental equation, an equation which contains polynomial as well as logarithmic function, exponential function and trigonometric function etc. are called transcendental equation. Examples of transcendental equation are x e power 2x minus 1 equal to 0, cos x minus x e power x equal to 0 and tan x equal to x. These are the examples of transcendental equation. Next, we need to know what is the root of the equation. A number alpha for which f of alpha equal to 0 is called the root of the equation f of x equal to 0 or 0 of f of x. Next, we need to know where the root lies between the interval. For this, we call that to be as location of the roots. If f of x is continuous in the interval a comma b and if f of a and f of b are in opposite signs, that is f of a and f of b have opposite signs, that is f of a will be negative, f of b is positive, or f of a is positive, f of b is negative. So opposite signs, then the equation f of x has at least one real root lying in the interval a comma b. Methods of solving the equations are, there are various iterative methods to solve this equation. Some of them are methods of false position, iterative method, Newton-Raphson method and method of bisection. In this section, we are going to see the solution of solving the equation using Newton-Raphson method. Consider the equation f of x equal to 0. Assume that to be as equation 1. Let x naught be the initial approximation root of the equation. See, there is a curve with alpha be the root of the equation and x naught be the initial root of the equation. Let p be the point x naught comma f of x naught. Now we are going to draw a tangent to the curve at p. So we have drawn a tangent to the curve at the p. The p which intersects with x-axis, which intersects at x-axis, we consider that to be as a next initial root. This process will be repeated until we get a required accuracy is obtained. The equation of the tangent y equal to f of x at the point p x naught comma f of x naught is y minus f of x naught equal to x minus x naught into f dash of x naught. Where f dash of x naught is nothing but the slope of the curve. Setting y equal to 0 and solving for the x, we get x is equal to x naught minus f of x naught divided by f dash of x naught. This is nothing but the next initial root, that is x1. So x1 can be represented as x0 minus f of x0 divided by f dash of x0. So repeating the process for x2, x3, etc. up to x4 up to xn are obtained using the iterative formula. So the Newton iterative formula is xn plus 1 equal to xn minus f of xn divided by f dash of xn. This is called to be as Newton-Raphson method or tangent method or chord method. So we call that to be as Newton-Raphson method or tangent method or chord method. If the initial approximation to the root is not given, we consider the smallest interval containing of the root of f of x, say a comma b. For this we can able to check these conditions. One is if modulus of f of a is less than modulus of f of b, we consider the initial approximation root to be as x0 equal to a. The next is if f of b is less than modulus of f of a, that is modulus of f of b is less than modulus of f of a, we consider the initial root to be as x0 equal to b. That is the meaning that x0 equal to a means f of a is nearer to 0 when compared to f of b. In this condition, modulus of f of b is less than modulus of f of a means f of b is very nearer to 0 when we compare to f of a. Let's see some of the few problems which is asked under the gate questions. First one, the equation x cube minus x square plus 4x minus 4 equal to 0 is to be solved using the Newton-Raphson method. If x equal to 2 is taken as the initial approximation of the solution, then the next approximation using this method will be. So here what are the things is given means they given x0 to be as 2, that is the initial approximation. So they given x0 to be as 2 and the given equation we consider that to be as f of x, that is f of x equal to x cube minus x square plus 4x minus 4. They ask us to find the next approximation of the root, that is they ask us to find x1 value. So using the Newton-Raphson method, we know what is our x1. x1 is nothing but x0 minus f of x0 divided by f dash of x0. So we know what is here x0. Substitute the x0 value in the x1. x1 is equal to x0 value is 2. So 2 minus f of 2 divided by f dash of 2. So we need to know what is the f of 2 and f dash of 2. Substitute the x0 equal to 2 in the given equation f of x. We will get f of 2. So f of 2 is equal to 2 cube 8 minus 2 square 4 plus 4 into 2 8 minus 4 which is equal to 8. Next we need to know the derivative of f of x. F dash of x is equal to differentiating x cube with respect to x, it will be 3x square minus x square 2x. When you derive 4x, it will be 4. Now substitute the x0 value over here, that is 2. F dash of 2 is equal to 3 into 4, 12, minus 2 into 2, 4, plus 4. On simplifying this, we get the f dash of 2 value to be 12. So we know the x0 value, we know f of x0 value and f dash of x0 value. Substituting that, 2 minus 8 by 12. Simplifying this, 2 minus 2 by 3. Further simplifying this, we will get 4 by 3. So the right option is 4 by 3. That is B1. We're moving to the next one. The recursion relation to solve x equal to e power minus x using Newton-Raphson method. So here before case they ask us to find the next approximation root. Here in this case they ask us to find the recurrence relation using Newton-Raphson method. So what is given in the problem? F of x is equal to x minus e power minus x. So we consider the given equation to be as f of x. I rewrite that equation to be as x minus e power minus x. We know the Newton's formula. Xn plus 1 equal to xn minus f of xn divided by f dash of xn. So here there is no initial root. They ask us to find the recurrence relation. So we consider the given function f of x in place of x to be as xn. So I am keeping the xn as it is. F of xn, in place of x we are going to replace the n, that is xn. We will get f of xn to be as xn minus e power minus xn divided by, next we need to find the derivative of f of x. So derivative of this one, f dash of xn equal to, differentiating x n with respect to x, it will be 1 minus exponential of derivative, it will be e power minus x into minus 1. So this is nothing but 1 plus e power minus x. So we know what is the f dash of xn. So substitute that value. So 1 plus e power minus xn. On simplifying this, we will get cross multiply x power n plus xn e power minus xn minus xn plus e power minus xn divided by 1 plus e power minus xn. Plus xn minus xn will be get cancelled. Taking e power minus xn common, you will get xn plus 1 divided by 1 plus e power minus xn. This is the recurrence relation of the given equation. That is nothing but option C is the right one. Moving to the next one. We wish to solve x square minus 2 equal to 0 by Newton-Raphson technique. Let the initial guess be x naught equal to 1. Subsequent estimation of x will be what? So they are asking the subsequent of estimation, that is nothing but x1. They ask for the next initial root. So we are going to find the x1 using the Newton-Raphson method. We know the formula for this one. x1 is equal to x naught minus f of x naught divided by f dash of x naught. And the given problem already given the initial root x naught to be as 1. So given x naught to be as 1. And we need to know what is the f of x and f dash of x. We consider the given equation to be f of x. Next the derivative of this one, 2x. So we know f of x, we know f dash of x, we know the x naught value. We are going to substitute that one in the initial approximation root value in the next approximation root. For this we need to know the f of 1 value and f dash of 1 value. Here you substitute the x naught value 1, it will be 1 square minus 2, which will be 1 minus 2, which is equal to minus 1. Similarly in the derivative, f dash of 1 equal to 2 into 1, which is equal to 2. Substitute these values in the x1. So x1 is equal to x0 1, f of x0 minus 1, f dash of x0 is 2. So 1 plus 1 by 2, which is equal to 3 by 2, which is nothing but 1.5. So option B is the right one. Moving to the next question. Starting from x0 equal to 1, one step of Newton-Raphson method in solving the equation x cube plus 3x minus 7 equal to 0 gives the next value x1. So they ask us to find the next iteration, that is next approximation root using the Newton-Raphson method, and they given initial root to be as x0 equal to 1 and f of x given to be as x cube plus 3x minus 7. So we know the next approximation root x1 can be calculated as x0 minus f of x0 divided by f dash of x0. So here the x0 is given to be 1. So 1 minus f of 1 divided by f dash of 1. So we need to know what is the f of 1 and f dash of 1. For this, the given equation, we consider that to be as f of x, x cube plus 3x minus 7. In this equation, you substitute 1, we'll get the f of 1, 1 cube plus 3 into 1 minus 7. So 1 plus 3 minus 7, that is 4 minus 7 equal to minus 3. Similarly, we need to know the derivative of this one. So f dash of x is nothing but 3x square plus 3. Substitute the x0 value over here. So 3 into 1 square plus 3, which is equal to 3 plus 3, which gives 6. So we know f of 1 value, f dash of 1 value, substitute in the x of 1. So x of 1 is equal to 1 minus of minus 3 divided by 6, which is equal to 1 minus of minus, it will be plus 1 by 2. It's nothing but 3 by 2. It is simplifying, we'll get 1.5. Therefore, option C is the right one. Thank you, students. We'll see the next session in the next video. Thank you.